Thank you. I thank the organizers for inviting me to present the very preliminary results of the study of this reactivation of oxygen transference rate of staves after having been regenerated. So I'm happy to be at the forum together with Antonio. First of all, I shall explain how a barrel works, because apart from being a container which transfers aromatic substances that we all know, and the other reason why we choose one type of barrel or another, it is an interactive container which interacts continuously and modified with wine and being modified over time. The important thing is that oxygen goes in, and different authors over the years have proven that oxygen entrance, and we express it by oxygen milligram per liter per year. We start from the studies by Ribeiro Gaillon in 1931. He assessed that oxygen entrance, which over 6 months he could assess that amount around 15-20 milliliters of milliliters liter per year. Then we have Peterson work in 1976 with much lower values between 2.8 and 7 milliliters per liter per year. Motorhead should also be mentioned in 1994, between 15 to 20 milliliters a year. And Vivas Glories with a different value, but similar, 10 to 28 milliliters. And then in 2003, Kelly and Wallen established that the way the barrel worked from the oxygen transfer point of view, it could be regarded as a membrane that transfers oxygen depending on its thickness. So they estimated that rate on 26 milliliters per liter per year. So the oxygen goes in the barrel. It has been proven. And how could it go in? Well, oxygen can go in through the joints between staves or through the wood, or obviously when we open the stopper, when we fill it. All of this makes the wine to enrich, thanks to large or small amounts of oxygen, making wine evolve and giving it final features. We have been measuring this entrance in the barrel for a number of years using a method which currently offers a measurement, an optoluminescent measurement with gauges that go in through the stopper. These are gauges which do not burn oxygen, and through this airtight stopper we can analyze the amount of oxygen accumulated in the interior. So we need to have a liquid. We have synthetic wine, which is 14% proof and pH 3.5 deoxygenated. If we had oxygen, then we wouldn't see how oxygen is accumulated, because otherwise it would be rapidly consumed by the wine. So what we do is gathering measurements of how oxygen accumulates within the barrel over time, and therefore we get an input rate. And if we extrapolate to what happens over the year, this is the transfer rate, milligram per year, over a year. To this, we make a global measure, so we have a global transfer rate value. I want to know how much goes in through the wood and how much goes in through the stopper. In our case, we use a perfectly airtight stopper, so we know no oxygen is going in through it. So the total measurement of oxygen, we measure it, then we seal the joints between the staves on the sides and at the bottom and top, and we measure the oxygen transfer. So we have the transfer rate through the wood. Our work showed us, as we can see on this slide, on one hand, 4 barrels of the same lot made with American oak, and 4 of the same lot, but made with American oak, and we see through the French oak more air goes in, on average 21 milligram liter year, That represents 77% of all the oxygen received by the barrel. But in the case of American oak, the amount of air is much lower, almost 16 milligram liter a year, and the rest is what goes through the joints. Therefore, thanks to this experiment, we can see air goes in through the wood and through the joints, and this happens throughout the aging process. We saw that it doesn't, not all along. The oxygen transfer varies over time. There's an experiment we carried out along a year with 4 barrels. We filled them with model wine, synthetic one, and we analyzed how oxygen was accumulating. We stopped the experiment. We refilled with a deoxygenated wine to make sure that the difference is exactly the same inside and outside. Inside will have the real wine, and it's always going to be very low, so this trend to going is what regulates the oxygen transfer, and that entrance rate is going down over time. So all the values we were using until then are overestimating the amount of oxygen going in, because if we make a reading over a year, over a month, the rates are 29.4 liter a year. Then if we analyze it for 3 years and we apply it to the whole year, then it'll be 15.4. But if we use the analysis of a full year, the average is 11.5 milligram liter a year. So it is a dynamic rate which changes over time. In this case, we see the results of these 4 barrels with readings carried out over a full year on 15 occasions, and we can see that the real rate is around 10-12 milligram liter a year. Another interesting thing is that in the first 40-50 days, the wine has received 37% of the total oxygen it's going to receive over the year. So, having understood this is the way a barrel works, then we place our data of 10-12 milligram a year is our reading, that is our reading. So the barrel acts as a container which is impregnated with one. Then there are losses, of course, that creates a space at the top, an empty space, depending on the size. There will be more or less room, then there is air going in, and that will go through the wood and the joints of the whole barrel, and that is regulated by the flooded layer, and therefore it is a dynamic rate of oxygen entrance. So the barrel works this way. So now let us explain the results obtained assessing the wood samples obtained both before and after the procedure. I think you have all seen these barrels. These pictures are on the web, but they're also outside on the Barena stand, and you can see the great difference between the internal part of the barrel after this experiment. This is the case of 2 photographs of how the barrel is on the inside, and once the regeneration, reactivation has been done, the aspects of the wood on the inside. So what we did was a preliminary study analyzing 3 different years barrels, 2007, 9, and 13, choosing 4 staves on each barrel, 2 at the bottom part and 2 at the top part. So 15 samples were analyzed, extracted before the regeneration, and also samples which are close to the piece of wood that was chosen for the previous analysis. This is what the samples look like before and after. And these are 4 of the staves that we have seen, what the treated wood, non-treated wood, and how it was analyzed. How was this analyzed? These wood samples, the analysis was done with a device was patented in 2014 by a group which reproduces the barrel scenario. So we place a piece of wood in contact with air on one side and in contact with a liquid on the other side. We, of course, will be soaking and modifying the stave as it happens in a barrel, but which contains a deoxygenated liquid with an oxygen sensor which measures the oxygen transfer, and if it was real wine, then we'd be using it up very quickly. Thanks to this device, we had some oxygenating rates before and after. These are the results. These results show us that the staves at the bottom part, in all the cases, give an oxygenation rate which is quite higher to that of the samples which are in touch, the staves which are just beside but not treated, and these results are not the same on the bottom part staves. On the bottom part, we see that only in the case of the 2007 barrel, we find an increase of reactivation after the treatment. These results are preliminary. They're very early. These are the samples I just described, and if we wanted to know how we can apply this data to a real barrel, we could think that the two staves chosen at the top are 50% of the whole barrel, and the two at the bottom would be the other 50%. Or we could think that really, as the bottom ones will be more dirty due to precipitación and clarification, spontaneous, that spontaneity takes place during aging, then we can work out, we can use these figures to work out how much oxygen would go in through the wood in the whole barrel. So, applying this extrapolation, we can find these two situations represented by the bars, by the columns. For the 2007 barrel, 2009 and 2013, we find that in all cases there are statistically significant differences, and we can say that the barrel does reactivate the oxygen entrance. If we want to see the results in milligram per liter per year, we move from 11611 to values of 3759 and 21. That is, we're multiplying by 2, 4, or 7 times the oxygen uptake. This is very interesting, it is encouraging, and it is extrapolation to the barrel. So what happens if you want to compare it with a new barrel? Of course, we do not know the oxygen transfer of these new barrels, but we know through the experience of the barrels we've been measuring over the years that French barrels will allow a higher oxygen entrance than American barrels, and we can see here that according to previous results that I've described, in the case of American barrels, approximately 50% can go in through joints and the other 50% through the wood, and for the French barrel, much more through the wood than through the joints. Based on this situation, we can think that if these barrels were oak, American oak, then they would stop transferring 30% of all the oxygen, if they're new, to 41% of the total, which is a good regeneration and a good reactivation. If it was French oak, then it would be, they would be transferring from 10%, they go up to 32%. So these results, through these results we can establish preliminary conclusions. So reactivation regenerates oxygen entrance through the staves of the used barrel. We recover between 2 to 4 times the oxygen entrance versus the non-regenerated wood, analyzing the contiguous wood not regenerated. All of this will depend on the condition of the barrel, the type of oak, the type of wine, the time, number of uses, and now we are work is in process to assess the barrel as a container for the effect it has globally between barrels and joints, staves and joints. The work was carried out by the UVaMOX group, formed by the persons you see on the screen, and researchers and postdoc hired personnel. We are in Valencia, the higher agrarian engineering school, and if you want to find out about us, please visit our blog and our webpage, where we try to show all we find out about oxygen in wine, both through our studies and by our colleagues' studies. And I should talk again about the book, but I think you all are aware of it by now. Thank you.